Okay, in this video I'd like to continue doing example problems, and here I'm going to do problem number 9 off the midterm. And in this problem we have an access control list given here, and I want you to make a diagram that shows what it does and then figure out a way of implementing the ACL using fewer lines. Okay, and so let's see. I guess I'll do it right on this page. And what I'm going to do is I'm going to note that this is a sort of all the action is happening within a Class C network. These are all, the first 3 bytes are the same. And so what I'm going to do is I'm going to write down a little picture representing the IP address space of a Class C network. Okay, and so what I'm going to do is I'm going to make a sort of a hierarchical divisions by power factors of 2, and I don't think I need this lower one, but here it is anyway. So this represents 256 IP addresses all the way across. Here's the first 128, here's the second 128, so this is a division into 128s, 64, 32, 16. So each of these little squares represents 16 IP addresses. And what we're interested in is this ACL. And so what I'll do is, so what we have to do is we have to look at what subnet this represents, and this is the wildcard mask. And if you'll recall, the wildcard mask is kind of nice because it gives a number at the end which more or less specifies the number of IP addresses in the range. Okay, and so for example, if we have a 31 here, we have 32 IP addresses in the range that match this wildcard. Why is that? Because a 31 is a binary 1, 2, 4, 8, 16 1, 2, 3, 4, 5, 6, 7, 8. That's a binary 31. And you'll recall, so that's the last 8 bits of that subnet mask. And you'll recall that, and the rest of them are zeros, that for the zeros, we need a match. And for the ones, that's the wildcard match. And so the last 5 bits can be anything, and it matches. So you take this address and let the last 5 bits range from 0 to 31, and they all match because it's only those last 5 bits that are changing. Okay, so it's very easy to look at this diagram and look at these numbers in the ACL and just draw a picture of what's going on here. So this is going to match starting at address number 64, and it's going to match 32 addresses starting at address 64. Well, this is address 0. This is address 255. And so address 64 is, it's easy. You just go up to the row that has 64 on it, and that's the beginning of address 64. And we're going to match a block of addresses 32 wide. Well, here's the level at which we have blocks of 32. So this is going to be a permit. And this is, I'm going to label it with a 1 because that's the first item in that access control list. Okay, so I'm going to permit that block of IP addresses from 64 up to 96. Then I'm going to permit a block starting at the same spot, which is 64 wide. So I'm going to permit, and I'm going to put a 2 on that P because it's second in a row. Next, I'm going to deny a block starting at address 128, which is 128 wide. Now I'm going to deny this entire block up here, starting at address 128 and of width 128. And I'm going to put a 3 on that. Finally, I'm going to permit one of with 32 starting at 192. I'm going to permit this group here, and then the last step number 5 is I'm going to permit a group of with 32 starting at 192, and that's right over here. And you just have to do that. You have to figure out, well, what is this? This is 3 times 64, or 192. 192 plus 32 is 224. So you got to figure out where these things start. Okay, and hopefully this number here is consistent with that one, so that it starts on one of these boundaries, or else it won't make any sense. Now, these ACLs have what's called first match logic. Okay, and what that means is as soon as we get, so we have an IP address which is coming through the router or the firewall, and that IP address is being compared to the list of addresses in the access control list. And the access control list is going to tell us whether to permit or deny the routing of those packets. And so we're looking for an IP address. We're looking for our IP address to match one of these ranges here. Okay, and as soon as it matches one of these ranges, it stops looking. Okay, that's called first match logic. And you can see here that first step we look in this range, second step we look in this range, third step we look in this entire range. And so as written, these last 2 steps are never going to be executed, because anything that would match either of their ranges has already been matched on step 3's deny, because it's such a large range. In other words, this range is a superset of the 2 ranges for steps 4 and 5. Steps 4 and 5 will never be executed in this case. And so to shorten this, we can eliminate them. Another way of shortening it is to realize that step number 1 is a subset. The range specified in step 1 is a subset of the range specified in step 2. In other words, anything that matches range 1 is also going to match range 2. We might as well skip line number 1 here, because line number 2 will do exactly the same thing. That is, anything in this range from 64 to 96 will also be permitted by step number 2 here. In other words, what I can do then is I can simplify this thing greatly by number 1, I'm not going to make my diagram go down so far. I only need it to go down to the 32 level here. And so I'm going to simplify this by saying I'm going to pass this group and I'm going to deny this group. And because these 2 ACL entries are on disjoint sets of IP addresses, it doesn't matter what order they're in. And so I'm going to say this is the shorter version, and I can write it as access list 22. I can say permit, and I'm going to permit exactly what step 2 was, 192.168.85.64.000.63, and then I'm going to deny, and it's exactly what line 3 was. So all I have to do is save lines 2 and 3. .128, 0.0.0.127. And so this is a 2-line ACL, which does exactly the same thing as that. Oops, I'm sorry. Okay, well, in any case, I copied this diagram over down here. And here I've permitted exactly the same group that was in P2. Here I've denied exactly the same group that was in step 3 up above. Okay, so here I permit, here I essentially just copied down line 2 from above and copied down line 3 from above. Barely fits. Okay. In fact, that's not exactly the problem I wanted to have on the exam, but this is how you solve the problem as written on the exam. So hope that helps.